In this problem, we are using the substitution method to find an indefinite integral, and this time we're doing it with trig functions. So if you don't have all your antiderivatives and derivatives of trig functions memorized, having this chart handy will probably be helpful. Actually, just glancing at this problem, it's got cosecant x times cotangent x, and then it's got a negative cosecant x down here. I'm clued in that this is the thing we're going to need to be looking at, this line down here. So with U substitution, what we're always trying to do is see if there's a relationship between parts here where one part is the derivative of the other, because that's going to enable the substitution to happen. And I can see, now this is an antiderivative chart, so if you want the derivative, you just go in the other direction. The derivative of the negative cosecant is the positive cosecant times the cotangent. So we've got the negative cosecant down here, the positive cosecant cotangent up here. So that's what we need to do. This tells us that we're going to make our u this stuff. So u equals 5 minus 2 cosecant x. And what we do next is we take the derivative of u with respect to x. So du dx, and 5 just goes to 0, and then we've got negative 2 cosecant x. So we're going to have the 2. Remember, the negative cosecant goes to a positive cosecant cotangent. So this is positive 2 cosecant x cotangent x. And then I'm just going to multiply by dx on both sides. We get 2 cosecant x cotangent x dx. And then I want to get rid of this 2 as well, so I'm going to divide both sides by 2. And what I get is 1/2 du equals cosecant x cotangent x dx. So what I was trying to do there is just get it down to this bit and this bit. And then we're going to use this, we're going to substitute that in for those bits. I think the last thing I'm going to do to get ready for this is rewrite this as a product rather than a quotient. So we're going to call this the integral of the cosecant x times the cotangent x times 5 minus 2 cosecant x to the negative 8th power dx. Now, when we substitute, u is going to go in here, and this, all of that stuff is right there. So that's 1/2 du. So, and this is all multiplied together. So I can just call this u to the negative 8th times 1/2 du. And then I want to get that half out of there. Luckily, I can do that. I can just pull it out front. So I'm going to pull out a 1/2. And then we've got, whoops, u to the negative 8th du. And once we've got the u du form here, we can take the integral, the antiderivative of that pretty easily. We're just going to raise the power by 1. So that's u to the negative 7. And then we're going to multiply by the reciprocal, which is negative 1/7. And then we've got this 1/2 hanging out here as well. So 1/2 times negative 1/7 equals negative 1/14. And then we're going to substitute back in our u to the negative 7th here. And our u is, of course, 5 minus 2 times the cosecant of x. 5 minus 2 cosecant x. And that's done except for adding the arbitrary constant. And so we've used U substitution to find an indefinite integral of a trigonometric function.